Imagine standing on the moon, looking back at Earth, and taking a deep breath of oxygen that was literally melted out of the dirt beneath your boots. In 2026, I mean, that is no longer science fiction.
No, it completely rewrites the rules of, deep space survival.
Right. So today we are doing a deep dive into a massive stack of 2026 sources. We've got Wikipedia entries, RCIF preprints, MIT Tech Review lists, industry reports.
Yeah, we are extracting the absolute biggest breakthroughs of the year.
Exactly. And we're treating this deep dive like your ultimate master study guide for a massive 2026 science and tech exam. We're going to help you cram the essentials without the overwhelm.
Yeah.
So, okay, let's unpack this, starting with the orbital mechanics portion of your exam.
Right. So the biggest shift in space exploration right now is happening with the Artemis II mission and Blue Origin's latest milestone. We're finally moving past just going further into space.
Like Artemis II breaking the Apollo 13 distance record by taking humans 252,757 miles away.
Yeah, which is incredible, but we are also figuring out how to actually stay there.
Right, because Blue Origin successfully extracted medical-grade oxygen from melted moon dust. But how exactly are they doing that? Because squeezing water from a stone doesn't quite cover the physics of it.
Well, the lunar soil, or regolith, is actually nearly half oxygen by weight, but it's entirely locked up in oxidized minerals. What they've done is develop a way to superheat that dirt until it's molten and then run an electrical current through it.
Oh, so like electrolysis.
Exactly. It breaks the chemical bonds, separating the liquid metal from the oxygen gas.
Which fundamentally alters the grading curve for surviving out there because of in situ resource utilization.
Yeah.
Shipping heavy tanks of oxygen out of Earth's gravity well is just insanely expensive.
It really is. If you can bake your own breathable air out of the ground you're standing on, permanent lunar bases suddenly become economically viable.
Okay, but moving from surviving in space to ensuring we can still survive on Earth, let's look at the Earth Sciences exam.
Yeah, that exact mindset of extreme resource management is violently colliding with our reality back down here because while we are mastering the lunar environment, we're seeing terrifying predictions about our own.
Like the AMOC.
Right. The latest models show the AMOC, the Atlantic Meridional Overturning Circulation, is projected to weaken by 42 to 58% by 2100.
And just to clarify the mechanism there,
Huh.
the AOC is essentially the ocean's global conveyor belt. As melting ice caps dump massive amounts of fresh, less dense water into the North Atlantic, it disrupts the sinking of cold, salty water that drives the whole current.
Yes. And if that slows down by half, we're talking about a catastrophic collapse of global rainfall patterns.
Which is terrifying.
It is, which is exactly why we are seeing a desperate parallel explosion in clean tech deployment. Like, MIT is highlighting compact next-gen nuclear, and QuantumScape just inaugurated its Eagle line.
Which is a huge manufacturing pilot for solid-state EV batteries using something called the Cobra process. But wait, I have to push back a bit here, though.
Yeah.
So we are celebrating better EV batteries while major ocean currents are actively collapsing. I mean, it feels a bit like desperately bailing water out of a sinking boat while praising our shiny new buckets.
Well, if we connect this to the bigger picture, it is not just about shiny new buckets, it's about sheer manufacturing speed.
How so?
The Cobra process is a major breakthrough because it rapidly layers solid ceramic electrolytes instead of the flammable liquid ones used in older batteries. It makes these hyper-efficient batteries vastly more scalable.
Right.
We're running a literal sprint between crossing irreversible climate tipping points like that AMOC collapse and the global scaling of next-gen nuclear and advanced batteries.
And to optimize all these clean technologies, we require an entirely new paradigm of computing and infrastructure, right? So let's turn to the computer science exam.
Yeah, because classical computers just hit a wall. In 2026, 6G is formally standardizing.
Which is the massive connectivity backbone required for hyperscale AI data centers.
Exactly, and to support the booming humanoid robot market that ID Tech X has been tracking. And underneath that macro-level infrastructure, the micro-level processing is taking a massive leap.
With quantum computing.
Right, Quantinuum just achieved near break-even, fault-tolerant quantum computing using the Steam code.
Here is where it gets really interesting. For anyone cramming for the quantum portion of this exam, you can think of the Steam code like a hyper-advanced autocorrect. In quantum computers, qubits are incredibly fragile, right?
Oh, incredibly. They're prone to errors from the absolute slightest temperature change.
So this code predicts and fixes those quantum typos almost as fast as the hardware makes them, stabilizing the system before it crashes.
And that stabilization is crucial because we are asking our software to do incredibly complex reasoning now. Take the new VenaStar framework. It uses an AI virtual expert panel to actively reason through biological protein mutations.
It's basically like a group of students doing a group project, but for hyper-advanced science. You have different AI agents arguing over the biology, auditing each other's work against biophysical constraints, and actually reaching a consensus.
What's fascinating here is the complete shift in agency. AI has transitioned from being a passive tool, where you punch in a query and get a summary, to an active, collaborative scientific reasoner. It's generating novel hypotheses on its own.
Well, you are officially prepped for the exam. This isn't just trivia. Understanding these converging fields is your absolute shortcut to being well-informed for the 2030s. So what does this all mean?
It means humanity is rapidly building tools that can outpace our own capacity to understand the physical world just in time to try and save it.
And here is a final provocative thought to leave you with. MIT recently highlighted how humans are forging increasingly intimate relationships with AI companions. If AI is providing our emotional companionship and autonomously reasoning through our biology, will the students cramming for the 2036 exam even be human?